Okay, so now we're going to run through another Hess's Law model answer to an exam question. So our first question is, write an equation including state symbols for the formation from its elements of solid sodium sulfate, which they tell us is NO2SO4. Now what, in other words, this is asking us to do is write an equation to represent the standard enthalpy of formation of sodium sulfate. So the key bit to note here is that standard enthalpy of formation is when 1 mole of compound is formed from its constituent elements. So when we put our compound Na2SO4 as our product, we cannot put another number of moles in front of that. It has to be 1 mole. They will not allow multiples on this type of question. So from its constituent elements, so we must have sodium, sulfur, and oxygen, which obviously we should recognise by now is diatomic. So they tell us in the question that sodium sulfate is a solid. So the state symbol for sodium sulfate is going to be small s. Standard enthalpy of formation is from its constituent elements in their standard states. So we should know oxygen is a gas, little g. Sulfur is a solid, and sodium is also a solid. Then the last thing we need to do, and this will get us the second mark, is just balance that out. So we've got 2 sodium atoms, 1 sulfur, so that stays as it is, and we've got 4 oxygen atoms, so we need 2 lots of O2. So some standard enthalpy changes are difficult to measure directly, but can be determined from standard enthalpies of combustion. So here we are working with standard enthalpies of combustion. Maleic acid C4H4O4 reacts with oxygen to form carbon dioxide and water as shown by the following equation. That's your delta HC for maleic acid. Use the standard enthalpy of combustion data given below to calculate a value for the standard enthalpy change for the following reaction, and we can see that that is the formation of maleic acid. It's a formation reaction. Down the bottom here we're going to have our combustion products, which they tell us are 4 carbon dioxides and 2 water. The data we've been given is standard enthalpy of combustion when 1 mole of substance is completely burned in oxygen. So we are going from the compound down to the combustion products to carbon dioxide and water. So that one is for maleic acid, which is minus 1356. Obviously there's only 1 mole of that, so it stays as it is. Then when we combust carbon, we've got minus 393.5, but obviously now we need to recognise that we've got 4 moles of that. So we're going to multiply that by 4, and then for hydrogen it is minus 285.8. We've got 2 lots of that, so that is going to get us minus 571.6. Now if we call this side of the equation going from the constituent elements to the combustion products delta H1, and this side of the equation going back up from the combustion products to the product delta H2, Hess's law tells us that the enthalpy change for a reaction is the same regardless of the route taken from reactants to products. So delta HF going across here is the same as delta H1 plus delta H2. Now, if we look at delta H1, we're going with the arrow, so the sign is going to stay the same. So that's going to be minus 1574 minus 5716.6. But then when we look at going back up to maleic acid, we're going against the arrow. So we need to take that away. So it's take away minus 1356. You take away a minus, it becomes a plus. So if you put that all into your calculator, you should come out with a value of minus 789.6. And then again, we see up here that the units we are working with are kilojoules per mole. And that answer would get you the 3 marks.